Mars, the red planet. A world that has intrigued humanity for as long as we have gazed up at the night sky. It has captivated us for centuries, a beacon of mystery and wonder. From ancient civilizations who wove tales of gods and warriors, to modern scientists who seek to unlock its secrets. Its rusty hue, visible even to the naked eye, hints at a world of secrets waiting to be uncovered. This distinctive color is due to iron oxide, or rust, on its surface, giving Mars its nickname, the Red Planet. For generations, astronomers have peered through telescopes observing its changing seasons and polar ice caps. These ice caps, made of water and carbon dioxide, grow and recede with the Martian seasons, much like the polar regions on Earth. They dreamed of one day setting foot on its alien surface. The idea of humans walking on Mars has been a driving force behind countless space missions and scientific endeavors. Today, Mars continues to beckon, fueling our imaginations and driving our quest to explore the cosmos. With each new mission, we learn more about this enigmatic planet, bringing us one step closer to making those dreams a reality. Its proximity to Earth makes it a tantalizing target for our robotic emissaries, and perhaps one day, for human explorers. Robotic rovers like Curiosity and Perseverance have already begun to unravel the mysteries of Mars, sending back invaluable data and stunning images. But Mars holds another fascination: two small moons locked in an eternal dance around the red planet. Phobos and Deimos, named after the Greek gods of fear and terror, are as intriguing as Mars itself. These celestial siblings, Phobos and Deimos, offer a unique glimpse into the formation and evolution of planetary systems. Their irregular shapes and cratered surfaces tell a story of a violent past, possibly remnants of a larger body that was torn apart by Mars's gravity. Their stories are intertwined with that of Mars, and their secrets may hold clues to the very origins of our solar system. By studying these moons, we hope to understand more about the processes that shape not only Mars, but also our own planet and the entire solar system. The red planet beckons us, not just with the promise of new discoveries, but with the hope of understanding our place in the universe. In the annals of astronomical discovery, the year 1877 holds a special place. It was in August of that year that American astronomer Asaph Hall, observing Mars from the United States Naval Observatory, made a groundbreaking discovery. He identified two faint objects circling the red planet. These were no ordinary stars, they were moons, previously unknown and unseen. Hall named them Phobos and Deimos, after the Greek gods of fear and panic, fitting companions for the Roman god of war. These names reflect the moon's small size and swiftness, as they flit around Mars like fearful attendants. Their discovery sent ripples of excitement through the scientific community, adding two new members to our solar system's family of moons. Phobos and Deimos are not your typical moons. Unlike the Earth's moon, which is large and spherical, these Martian moons are quite unique in their characteristics. They are small and irregularly shaped, more akin to asteroids than to our own spherical moon. Their surfaces are covered with craters and grooves, giving them a rugged appearance. Phobos, the larger of the two, measures a mere 17 miles across, making it one of the smallest moons in the solar system. Its surface is marked by a large crater named Stickney, which is nearly 6 miles wide, while Deimos is a diminutive 9 miles in diameter. Despite its smaller size, Deimos has a smoother surface compared to Phobos, with fewer large craters. To put that into perspective, if Phobos were placed over New York City, it would barely stretch from Manhattan to JFK Airport. This comparison helps us understand just how small these moons are in relation to familiar landmarks on Earth. Their orbits are equally intriguing. Unlike the Earth's moon, which takes about 27 days to orbit our planet, Phobos and Deimos have much shorter orbital periods. Phobos whips around Mars in a blistering 7 hours and 39 minutes, faster than the planet rotates. This rapid orbit means that Phobos completes more than 3 orbits in a single Martian day. This means that if you were standing on the Martian surface, you would see Phobos rise in the west and set in the east twice each day. Its swift movement across the sky would be a spectacular sight, unlike anything we experience on Earth. Deimos, in contrast, takes a more leisurely 30 hours to complete one orbit, slower than the Martian day. This slower pace means that Deimos appears to move more gradually across the Martian sky. As a result, it lingers in the Martian sky for about 2.5 days between rising and setting. This extended presence in the sky would make Deimos a constant companion for any observer on the Martian surface, providing a steady, albeit distant, point of light. The gravitational interactions between Mars and its moons are also fascinating. Phobos is gradually spiraling inward towards Mars, and scientists predict that in about 50 million years, it may either crash into the planet or break apart to form a ring. This potential future collision or disintegration adds an element of dynamism to the Martian system, reminding us that celestial bodies are constantly evolving. Deimos, on the other hand, is slowly drifting away from Mars. Its stable orbit means it will continue to be a distant satellite for the foreseeable future, maintaining its quiet presence in the Martian sky. The orbits of Phobos and Deimos offer a glimpse into the dynamic and ever-changing nature of our solar system. These small, irregular moons, with their unique characteristics and intriguing orbits, continue to captivate scientists and space enthusiasts alike. As we continue to explore Mars and its moons, we uncover more about the history and future of these fascinating celestial bodies. The story of Phobos and Deimos is a testament to the wonders of our universe and the endless possibilities of discovery. A closer look at the surface of Phobos. Up close, Phobos is a world of craters, grooves, and dust. Its most prominent feature is a massive crater named Stickney, after Asaph Hall's wife, Angeline Stickney Hall. This colossal impact scar, spanning over 6 miles in diameter, dominates one side of the moon and speaks to a violent past. The impact that created Stickney must have nearly shattered Phobos, leaving it heavily fractured and covered in debris. Intriguingly, Phobos is also crisscrossed by a series of strange grooves or striations. These linear features, some extending for miles, have puzzled scientists for decades. Some theories suggest they are stress fractures caused by tidal forces from Mars, while others propose they are chains of secondary craters formed by debris ejected from the Stickney impact. Whatever their origin, these grooves add to the enigmatic allure of this small, battered moon. Deimos, a tiny world with big secrets. Deimos, though smaller and less dramatic in appearance than Phobos, holds its own share of mysteries. This tiny moon orbiting Mars at a distance of about 23,460 kilometers is often overshadowed by its larger sibling Phobos. Yet Deimos has a unique charm and a set of characteristics that make it a fascinating subject of study for astronomers and scientists alike. Its surface, while still cratered, is smoother than its larger sibling, draped in a blanket of regolith or loose dust and rock that obscures many of its features. This regolith is believed to be a result of countless impacts over billions of years, which have ground down the surface, giving it a more polished appearance compared to the rugged terrain of Phobos. This smoother appearance suggests that Deimos is older than Phobos and has had more time for impacts to grind down its surface. The age difference between the two moons is a subject of ongoing research, but the relative smoothness of Deimos' surface provides valuable clues about its history and the processes that have shaped it over time. However, Deimos possesses a unique characteristic that sets it apart. It appears to be covered in a layer of carbon-rich material, possibly deposited by comets or asteroids over billions of years. This dark, organic-rich coating is not just a superficial feature, it holds significant scientific interest because it may contain clues about the early solar system and the building blocks of life. This organic-rich coating has sparked speculation about the possibility of past or even present life on Deimos, though this remains highly speculative. The presence of organic materials raises intriguing questions about the moon's potential to harbor life, even if only in microbial form. Scientists are keen to explore these possibilities further, using advanced instruments and future missions to gather more data. Despite its diminutive size, Deimos continues to intrigue scientists, offering tantalizing hints about the early solar system and the potential for life beyond Earth. Its orbit around Mars, its unique surface characteristics, and the presence of organic materials make it a prime candidate for future exploration. As we continue to study Deimos, we may uncover more secrets that this tiny moon holds, shedding light on the mysteries of our solar system and the origins of life itself.